This week, guys, we're going to be looking at section 8.5, which is angles of elevation and angle of depression. This is involving trigonometry, but we have to be able to put this in a real world situation. So what we're looking at, first of all, is let's define these two things. What you see here first is angle of elevation. It's simply the angle that's between the observer's line of sight and a horizontal line. So like here's an example. You have this person, this is the horizontal line. It's always with respect to the horizontal, and they're looking up at something. So that would be your angle of elevation from the horizontal up to this angle, or up to this line. So that's what we're looking at for angle of elevation. Angle of depression, again, it's from the observer's line of sight looking down, but it's with respect to the horizontal, all right? So you can see up here, this forms a right triangle, okay? Down here, what ends up happening is the angle of depression is not inside the triangle, but because it's with respect to the horizontal, and we know that through if parallel lines are cut by a transversal, then alternate interior angles are congruent. So this angle and this angle are congruent. Those are the same thing. So now that angle is inside the triangle. That's going to help us with some of the problems we're looking at. First example here, guys, is looking at, says the angle of elevation from point A to the top of the hill is 49 degrees. If point A is 400 feet from the base of the hill, how tall is the hill? The hardest part about all of this is making the picture. I think once you get the right triangles drawn, you're just going to use those right triangle trig ratios to write equations and solve it. But drawing the picture is probably the toughest part. So angle of elevation, let's go ahead and draw this picture the best we can. So we're looking at, we have an angle of elevation. So at some point we're going to have a right triangle. So angle of elevation, so this is point A to the top of the hill is, so this would be 49 degrees. So from the horizontal up, angle of elevation. If point A, this is point A, and this is your hill over here, okay? If your distance from point A to the base of the hill is 400 feet, all right? And then they want to know how tall the hill is. All right, so here's your right triangle. Here's the hill. We want to find the height of the hill, or how tall the hill is. So now we have enough information. This is our unknown, okay? So what I'm doing again is going back to trig. Here's my angle inside the right triangle. I'm looking at the opposite side and the adjacent side. So opposite leg, adjacent leg, and that would be, if you remember SOHCAHTOA, that's going to be our tangent ratio. Now I'm going to write the equation. Tangent 49 degrees equals opposite over adjacent. So x over 400. And there's my equation. So now it's just a matter of solving that. I'm going to show all this. Multiply both sides by 400. Again, guys, show your work on these for me. And we're looking at x equals, and then it's just a matter of typing this in. So we're looking at 400 times tangent 49 degrees. I'm in degree mode. So we're looking at 460 would be, if we're just looking at the approximate value, 460. So the hill would be 460 feet tall. All right. And so that would be using the angle of elevation for that, just doing the trig. All right. Now this one, example 2, a person whose eyes are 5 feet from the ground is standing on the runway of an airport 100 feet from the control tower. So let's go ahead and start drawing that picture. So we know we have a control tower. And let's go this way this time. We have a person who's standing here, and they talk about this person's eyes are 5 feet from, so we got to consider that. All right, so this would actually be the ground right here. Okay. And it's 100 feet from the control tower. So we're going to go 100 feet. I don't think I'm drawing this to scale, but that's okay. So 100 feet. The person observes an air traffic control air traffic control person in the window up here, in the window at 132-foot tower. So we know that this entire thing, all the way to the ground, is 132 feet. Okay. But what we're going to find, because we have to subtract those 5 feet that were over here, so we're looking at this length is actually, what, 127 feet. Okay. And they want us to find this angle. We'll call this angle X. Okay. So we have all that set up. So let's go ahead and write our equation. Again, we're looking at opposite with respect to this angle, opposite and adjacent, that's tangent. So tangent of X equals 127 over 100. And, well, I mean, all we have to do to get X all by itself is do the tan inverse. Make sure you show this work. Okay, so clear that out from last problem. And we're going to go second tan, 127 divided by 100, so that we have tan inverse of that ratio. And we're looking at that angle of elevation. We'll round this to the nearest tenth, I guess. So we're looking at X is about 51.8 degrees. So that angle of elevation will be at 151.8 degrees. So let's go ahead and do one example with angle of depression. The search and rescue mission, our team is airlifting people from the scene of a boating accident. All right, so when they observe another person in need of help. So here's a situation. There's a helicopter up here, and the water's down here. So they're helping these people down here. So we're looking at that. It says the angle of depression to the person. So we're going to put this person over here. Okay. So this is the extra person. This is the boat, and this is the helicopter. It says the helicopter is 18 feet above the water. Now, it says the angle of depression. Remember, with respect to the horizontal. So from the helicopter down to here, that's going to be your 42 degrees. A lot of people make the mistake of trying to make it with the vertical. No. It's always from the horizontal. So 42 degrees here. And then remember that this angle and this angle would be congruent. So therefore, now we have this. It says, what is the horizontal distance from the rescuers to the person, to the nearest foot? So this is where the rescue would drop, and they're looking at what is the horizontal distance from here, how far would they have to swim, essentially. So that's our unknown. So even though the angle of depression is outside the triangle, we put it inside the triangle, and then now we're set. Again, this looks like a tangent. A lot of times these problems will be tangent, but not always. It depends on what you're trying to find. If you're trying to find the length of this, then you're going to use sine or cosine, depending on what else you need. All right, so let's write our equation. So we're going to go tangent 42 degrees equals 18 over x. You got to solve for x here. Again, show this work. These cancel, so I'm left with this. So all I have to do is type this in. So 18 divided by tangent 42 and the parentheses. And I get 19.99. So we're looking about, said to the nearest foot, so about 20 feet. So that horizontal distance would be 20 feet. So that's angle of elevation, angle of depression.